Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing how to actually graph rational functions. So if we're going through the full steps of how to graph a rational function, we have just a nice list of steps. First, and we even put a 0 next to the number just because you do it before you can do really anything else, you need to completely factor the numerator and denominator. All right? Then once you do that, you find all asymptotes and wholes. Again, as we talked about in the last lecture, start with wholes. Then you find all intercepts. So that includes the x-intercepts and the y-intercepts. Remember, for x-intercepts, you plug in, for either intercept, you plug in 0 for the opposite variable you're finding for the intercept. Then, if needed, you find all places where the graph crosses the horizontal asymptote, or you should at least try it. And then you also connect points and end behaviors. And if you have to, you may have to possibly test points. That's not always required, but sometimes it is. So sometimes. All right. So what's going on? So just like with the polynomial graphs, basically, we're going to make a bunch of points and a bunch of end behaviors, and we're going to try to connect them. Okay. There's a couple of things to note, though, when trying to determine these things. First off, a graph of a rational function will never, I'm going to underline it just for extra emphasis here, it will never cross a vertical asymptote. It can cross any other asymptote, but not a vertical one. Horizontal, that's why we have to check. If it crosses, the third step is where it crosses the horizontal asymptote. We do have to check that, and we will talk about how to do that. Okay? And all you have to do to see where it crosses is literally set whatever your horizontal asymptote is. Remember, it's a y value, equal to your function. So again, the function output, so like the f of x we have down here, that's a y value, that's an output. So whatever our horizontal asymptote is, we literally set it equal to that to find out where it crosses. There's some exceptions to that, and we'll talk about that coming up. Also, just to keep things in line in the thought process, when you're trying to find an x-intercept, basically you're trying to see when the whole fraction equals 0. So the whole rational function. But a whole rational function can only equal 0 if there's 0 in the numerator. So 0 divided by 3 that we have over here is equal to 0. All right? So we have, so if the numerator is 0, the whole thing equals 0. So the only way that the whole thing can equal 0 is if the numerator equals 0. Okay? And again, just like with vertical asymptotes, you want to find your x-intercepts after you've canceled out wholes to not have extraneous solutions. All right. So yeah, for x-intercepts, set the numerator equal to 0. For the asymptotes, vertical asymptotes, set the denominator equal to 0. But always before you do either, cancel a factor and cancel out the wholes, or cancel out the common factors and find the wholes. And again, lastly, just to reiterate, sometimes you may have to actually test a few values to see where on the x-axis, xy plane it is. If it's above normally it's just to see if it's above or below a certain value, or if it's above and below the x-axis. All right. Lastly, and this is kind of a separate thing, since we're finding x-intercepts, just like with polynomials, you could possibly have to worry about multiplicity, so whether it bounces or crosses. All right, with all that said, let's look at this. So very simple function, f of x equals x over x minus 2. So our first thing is to factor completely. Oh, you can't really factor x, you can't really factor x minus 2. So that's fine. There's no common factor, so we're going to go through. We always start with wholes first. There are no wholes. It's important to note. We then go to the horizontal asymptotes. We can just look at this term. So the degree here is 1, the degree here is 1. So they're the same degree. What's the leading coefficient here? Well, it's 1 in the top. The leading coefficient in the denominator is also 1. So we get 1 over 1 is 1. So we have a horizontal asymptote of y equals 1. We have a vertical asymptote. Again, since there are no holes, we can just set the denominator equal to 0 and solve. So we have x equals 2 as our vertical asymptote. We also have x-intercepts. And to find x-intercepts, we set y equal to 0. The opposite variable. Remember, the y in this case is the f of x. So 0 equals x over x minus 2. And the only way that this rational expression, or this rational equation, can equal 0 is if the numerator of this equals 0. So x equals 0. So what is the intercept? Well, we plugged in 0, and we set the whole thing equal to 0, and we solved for x. So 0 for x, 0 for y. And as a reminder, if you have 0, 0 for an intercept, for an x-intercept, that's why you should usually try to find the x-intercepts first, that is also your only y-intercept. You cannot have more than one y-intercept. Otherwise, it wouldn't be a function. So, what do we know? And by the way, when we set the top, that's of degree 1, so it's a crossing multiplicity. It's an odd multiplicity. So we have 0, 0 as a point. We also have a horizontal asymptote of y equals 1. So we graph with a dotted line, a dashed line, y equals 1. That's this. And we also have x equals 2. All right. So with y equals 1, x equals 2. And then we have this point. So this is where things get interesting for the intercepts. So, or for the in behavior. Remember that for our in behavior, they have to have, we kind of have arrows that we're going to or coming from. And for this, we're going to switch over to a pencil. We could have the possibility that, so we go from left to right, and this horizontal asymptote gives us the in behavior coming from the left. We have one of these two possibilities. We don't know if it's up here above it or down here below it. And this leads us to the idea of it could cross, again, it can cross any asymptote except possibly the a vertical asymptote. So we ask one last question. Crosses HA, the horizontal asymptote. So what is the horizontal asymptote? Y equals 1. Similar to how we found the x-intercept, we set 0 equal to the whole thing. Here we're going to set 1 equal to our whole original function. So when does 1 equal x over x minus 2? Well, we can multiply both sides by the LCD, which is x minus 2. To cancel, we get x minus 2 times 1 equals x. We're trying to solve, so we subtract x from both sides. As it turns out, when you do that, negative 2 equals 0. That's nonsense. Negative 2 never equals 0, which means there's no solutions. Which means, does it cross the horizontal asymptote? There's no way that we can't find anything where it does, so no, it does not. So we know that it doesn't cross the horizontal asymptote. That's crucial information. And we know that it either starts from here or here. What else do we know? We know that we're going from arrow to arrow. Where's the next arrow? Well, if we go to so we got a point here. But our next arrow is going to be at this on this side of the vertical asymptote. Okay, so we got to go from here to here because there's a horizontal asymptote and we don't cross it. So that's go from here to here, or down here from this arrow to this arrow. Logically, this has to be one of those. But what do we know? We also know that we have a point here. So what must happen? Well, since it can't cross, it must be from here to here. Not the best of graphs, but we know that this is generically what should happen. Something kind of like that. Now, so this top one and this one can't happen because if it did, we would have some y-intercept somewhere over here. That's another thing. So we can't have these, and it can't do anything funky like cross down and come up because we know that there was no place where it crosses the vertical or the horizontal asymptote. Now, so again, you go on graphs from left to right. So we found this side of the vertical asymptote. Now we need to find the other half, this side of the vertical asymptote. And as we saw, it can either go up or down, so it's either going to start up or it's going to start down. Which one it is, we don't know yet. But what we do know is that it needs to eventually go to the other arrow, which is the end behavior, which is from the vertical asymptote. So it either needs to go from here to here, or this needs to somehow go from here to here. Now what would happen if it was in the denominator? Well, if it started from here and went here, it would cross the x-axis. So we know that if it crossed that, we would have found an x-intercept, which we don't have. So we know without actually doing anything, without checking anything, we know it absolutely can't be this one because we found that there were no x-intercepts other than 0, 0, which we indicated with this one. So it must be this. So just like with the polynomials, you're still trying to play connect a dot, but you're also trying to connect one end of the end behavior to the other. And then you're starting again. So every time you do it, you're going from left to right, from one side of a vertical asymptote to the other. You have to do it again. All right. So we have one more example that's easier. We have some more difficult examples as well, but that will be for the next lecture. What if we have g of x equals 1 over x plus 1? All right, so let's just go through this. Let's go through all of our stuff. It's factored completely, so we don't have to worry about that. So are there holes? Nope, there's nothing that cancel. So what's after holes? Horizontal asymptote. The degree of the top, again, there's no x with an exponent, so it's degree 0. But in the denominator, it's degree 1. So what is the horizontal asymptote? The degree in the denominator is bigger than the degree of the top, so it's just y equals 0. Vertical asymptote, we have what? Well, we have a denominator, again, completely factored. We set that equal to 0. We get x equals -1. We also want to find the x-intercepts. And those occur when the whole thing equals 0. So when does 0 equal to 1 over x plus 1? Well, the numerator in this case is always 1. So if it's always 1, can it ever be 0? That's the only way the whole thing could be 0. No. So no x-intercepts. Okay, so we have the intercepts when y equals 0. What about the y-intercepts? Well, for that, we set x equal to 0. So again, the opposite variable of whatever intercept we're trying to find. So g of 0 is equal to 1 over 0 plus 1, which is 1 over 1, which is 1. So we plugged in 0, we got out 1. That is our y-intercept. And now, again, we have this new thing we need to check out. Does it cross the horizontal asymptote? Question mark. Well, if it did, where would it cross it at? It would cross it at the horizontal asymptote, which is y equals 0. But have we already set the whole equation equal to 0? Yes, we did. It's y equals 0 is here. This is the horizontal asymptote. So it crosses the horizontal asymptote when we have x-intercepts. So for a very specific type of horizontal asymptote, when y equals 0, you don't have to find where it crosses the horizontal asymptote because you already know. It's from the x-intercepts. So when does it cross the horizontal asymptote? At x-intercepts, but there were none. So does it cross the horizontal asymptote? No, because there's no x-intercepts. We then take all of this information and we plug it in. So we showed the horizontal asymptote, y equals 0. X equals -1 is a vertical asymptote. We also have, we plug in 0, we get out 1. 0, 1. And otherwise, it doesn't cross the asymptotes. So what do we know? Well, going from left to right, we know that it never crosses the asymptote, so it's either always above or always below. And we know 0, 1 is a point, so that, hey, it must start here. Again, as vertical asymptotes start up or down. And then it must stay above, so it must end here somewhere. So something kind of like that. All right. But what about over here? We have no way of knowing. So this is the first time where we actually have to test values. And all we have to do is test one value and see if it's above the x-axis or below. So if it's above the x-axis, meaning the y is positive, or below, meaning the y is negative. So all we have to do is test a value over here. Where is an x value? So when we're saying values, we're talking about x values. Well, -3 works. -1, -2, -3. Is it going to be above here or below? So let's just test x equals -3. You could test -2, -4. All those are fine. But what is g of -3? Well, it's equal to 1 over -3 plus 1. You remember g of x is 1 over x plus 1. So we go through and we plug that in, and we get 1 over -2, which is -1/2. So so if it's negative, that means it's not above the x-axis, it's below. So we must have something of this form. It can't cross the horizontal asymptote because we said it doesn't. So it must be entirely down here. And we get something like this. So this is what this graph looks like. This concludes this lecture.